This video is about something called midsegments. Midsegments connect two midpoints on a triangle. In the directions, we are told that points M, N, and P are all midpoints. That means that segment MN and PN and MP are all midsegments. Now here's one key thing that you need to know about a midsegment. A midsegment is going to be parallel to the opposite side. So midsegment MN is going to be parallel with side CE. In the same way, let's look at another midsegment. All right, how about midsegment PN? That is going to be parallel to CD. And now for the third midsegment, which we will do in green. Okay, MP is going to be parallel to DE. So let's look back at what we said. Segment CD is parallel to what? Well, CD is this purple segment here, so that is parallel to segment PN. What about segment DE? Segment DE is a green segment, so that will be parallel to segment MP. What about segment EC? Segment EC is this red segment, so it will be parallel to segment MN. Let's practice that skill for problem number 2. I went ahead and colorized the midsegment and the parallel side. So how about segment RS? Segment RS is this purple segment, so it will be parallel to segment MP. Segment SQ, that's a green segment, so it will be parallel to MN. Segment QR, that is a red segment, so that will be parallel to segment NP. Here is something else you need to know about a midsegment. A midsegment will always be half the size of the parallel side. So for example, if I told you that this midsegment MN was 5, then right away you would know that the parallel side CE must be 10. Or what if I gave it to you in a different way? What if I told you that segment RS was 12? And then I wanted to know what the length of the midsegment was. Well, that would be 6. So just keep that in mind as we look at problem number 3. So notice that VW is a midsegment. You can tell because of the hash marks that V and W are both midpoints. So VW is a midsegment, so it will be parallel to PR. But also, it will be half the size. So if VW is 9, that means PR must be 18. So let's go ahead and fill that in. What else do we know? They want to know the length of PV, but PV is right here. Okay, here is PV, but that is the same length as VQ. You can tell because they are marked equal. So if VQ is 6, that means that PV is also 6. And then what about PQ? Well, PQ is just the entire distance. So of course that will be 12. For number 4, ST is a midsegment. You can tell because of the tick marks that S and T are both midpoints. So the midsegment ST will be parallel to the side KI. But not only that, but the midsegment will be half the size. So that means that KI must be 8. So I can go ahead and write 8. We also want to know what the length of KJ is. Well, KJ is the whole way from here to here. So let's go ahead and start with, well, you know what, let me change colors. All right, let's do this side in green. If KS is 11, that means SJ is also 11, which means that KJ must be 22. So KJ is 22. Now we need to know what the length of IJ is. Well, that's going to be almost the same thing. If IT is 14, that means TJ is also 14, which means that the total distance from I to J is 28. All right, what about problem number 5? Do you see the midsegment in this picture? All right, segment PQ is the midsegment, so it will be parallel to segment TU. The midsegment should be half the size of the parallel side. So since SU is 30, then QP should be 15. And that's one of the things that we are being asked to find. Let's fill in some other stuff. For example, if QS is 7, that means that TQ is also 7. And that means that TS will be 14. So let's see, TS is 14 and TQ is 7. We are also being asked for UP. UP is right here. That's going to be half of 32. So this will be 16. So UP will be 16. And of course, PT will also be 16. Looking at problem number 6. The midsegment is DC. It will be parallel to XZ. But also, the midsegment is half the size. So if XZ is 19, then DC will be 9.5. What else? We are being asked for the length of CY. Well, if XC is 9, then CY will also be 9 because those are marked congruent. What about XY? Well, XY is the total distance, so that should be 18. That's just common sense. What about DY? DY is right here. That's the same as ZD, so this will be 6. And then ZY. ZY is the whole way, so that's going to be 12. All right, for problem number 9 and 10, we are going to solve some equations. Let's go ahead and highlight that midsegment, which is right here. That is parallel to this segment. So remember that the midsegment is half the size of the parallel side. So we're going to think of this as a half and a whole. So we know that in general, 2 halves equals a whole. So this will be our model. So the half is the midsegment. So 2 times 2x minus 3 should equal the whole, which is x plus 9. We have to do the distributive property here. So this will give us 4x minus 6 is equal to x plus 9. And then we will subtract x from both sides to get those x's together. That will give us 3x minus 6 is equal to 9. Next, we will add 6 to both sides, which will give us 3x equals 15. And finally, we divide both sides by 3. This tells us that x is equal to 5. So x is equal to 5. What about wy? Well, wy is x plus 9. So that's going to be 5 plus 9. So that's 14. So wy is 14. Let me make this really clear. So if this is 14, and that is going to be double the length of QR, then that tells me that QR is 7. Let's use the same logic on problem number 10. Let's switch over to purple this time. So here is the midsegment. It is parallel to this segment. So the midsegment is the half, and the parallel segment is the whole. So the model that we will use is 2 halves equals a whole. So that means 2 times x plus 2, right, that's the half, should equal 3x minus 8, which is the whole. Got to do the distributive property here, so we get 2x plus 4 is equal to 3x minus 8. Time to get these x's together. I like to subtract the smaller one just so that the x's will be on the same side of the equation. Just so I will get a positive x. So this will leave me with 4 equals x minus 8. Finally, I will add 8 to both sides. So that is going to give me 12 is equal to x. So we now know that x is 12. What about SQ? Well, SQ is this 3x minus 8. So since x is 12, that's 3 times 12 minus 8. So that's going to be 36 minus 8. So that's going to be 28. If SQ is 28, that's the whole. Well, ZY is half that, so it should be 14. Let's use the same logic on problem number 11. Switching colors one more time. I'm going to use green. So here's the midsegment, and here is the parallel side. Remember, in our minds, we are thinking 2 halves will equal the whole. The half is the midsegment, so 2 times x plus 19 should equal x plus 29. A little distributive property right here. And this is going to be 2x plus 38 is equal to x plus 29. Let's subtract x from both sides. This will give us x plus 38 is equal to 29. Next, subtract that 38 from both sides. And that's going to give us x is equal to negative 9. So x is equal to negative 9. Don't worry, x is allowed to be negative as long as the side length doesn't turn out to be negative. For example, we are asked to find the length of side CB. But CB is x plus 19. So that would be negative 9 plus 19, which would be 10. So we do get a positive value for the length of CB. And then for RT, we don't have to use the x plus 29. RT is double the length of the midsegment. So this should be 20. All right, what about number 12? One thing we have to watch out for. These are not midsegments anymore. So we cannot use any of the information that we've been doing so far in this lesson. We need to do something different. So I'm using this problem to help you avoid a common mistake. You see how similar this is to the problems that we've been doing. So you really have to pay attention to the fact that this is not a midsegment. You can tell because if this was a midsegment, then U would be a midpoint. So I have the 10 on the left, so I would have 10 on the right. But that would give me a total of 20, not 30. In fact, if DU is 10, I know that UF has to be 20. That's the only way the total will be 30. So right away you can see that U is not a midpoint. So this is not a midsegment, so we have to do something different. And here's what I want you to do. I really want you to draw the triangles separately. Here's what I mean. Let's draw the large triangle and then the small triangle. Okay, so here is the large triangle. And I'm going to move that down here. Oh, I missed a piece. Okay, here is the large triangle. Now, here comes the smaller triangle. Okay, so now we have the larger triangle and the smaller triangle. Remember that we know that this is 20. Let's label all of the vertices. So for the large triangle, this is D, and this is F, and this is E. For the small triangle, we have U, and F, and V. So let's label everything that we can. For the small triangle, UV is X, so I'm going to put an X right there. And then UF is 20, and then VF is 13. What about the large triangle? Well, the distance from D all the way to F is 30. So I'm going to put a 30 here. Notice it is not 10. A common mistake is to use the 20 and then the 10. But the 10 is only part of this side of the large triangle. You never want to use part of a side. So we're definitely going to do 30. Okay. And then DE is 66. So we can do that as well. So this is how we have to do it. Now we're going to do a proportion. I'm going to look at one triangle as new and one triangle as old. It doesn't really matter which one is new and which one is old, but we will set up our proportion in the form new over old. You know what, let me move this out of the way. We're going to set up our proportion in the form new over old is equal to new over old. So for example, I'm going to start with the X. So if I go new over old, that's going to be X over 66. And then I see I've got the 30, so I really need to deal with the 30. So I'm not going to wind up using the 13. So when I do new over old, I'm going to do 20 over 30 because those are corresponding sides. I like to reduce my fractions before I start cross multiplying, so I will have X over 66 equals 2 over 3. I just divided each of these by 10. So now I will cross multiply. That's where I multiply this diagonal and I put that on one side of the equation. So I've got 3x. And then I multiply this diagonal and I put that on the other side of the equation. So that's going to be 132. Now it's time to divide both sides by 3. So if I divide by 3, I'm going to get x is equal to 44.